Okay, it's an honor to be back. It's the second time presenting. I'm here with Maher Amr, our CTO, and who's the person, along with his team and engineering guys, that have essentially invented and developed this amazing product that we're here to talk about today, which is Memory One. So I think last time it was pretty interactive. So if people have questions, go ahead and interrupt me. I'm not sure how the other presentations went. Okay, so we'll talk a little bit about what we'll be presenting today. Okay, so I'll be talking a little bit about the company, just to let you guys know what Diablo is all about and what we've been up to for the last decade. I'm going to introduce Memory One at a high level, mostly try to talk about the problem it's trying to solve and the need that it's trying to fill in the market. And then, we want to get into basically what it is at a technology level, a little bit about how it works, and I guess most importantly, how does it impact the applications that people are testing? I think, I'm really excited to talk about that. The product is, is very targeted at web scale type applications, and we're going to be showing some, I think pretty remarkable results from a product that now is being tested in the market and, is essentially about to go GA. And so, Maher will be handling, the very technical portions of it, and then I'll kind of take over for the applications and whatever questions that we may have. Okay? So, thanks in advance for everybody's time and patience, and hopefully it's educational 2 hours. Okay? Okay, so a little bit about the company. We're based in Ottawa, Canada. The company is, founded by Canadians, and basically most of the research and development happens in Ottawa, Canada, and we're kind of from all over that northeastern area: Montreal, Ottawa, Toronto. We've got sales, marketing, and technical support in the U.S. on the West Coast, as well as now a growing presence in China, which is a very big focus for us in terms of the product. For obvious reasons, it's a big market and there's a lot of growth. So the company is starting to grow again. It's no secret we had legal issues around this time last year that we pretty much have very nicely cleared, recapitalized the company, and we're now very much focused on rebuilding the brand and the people and the technology, and clearly trying to solve the problems for customers, which is what we really want to do as a company. So it was a tough 2015, but is looking like an amazing 2016 for us, and we're really excited to get the year started. And this is obviously an event that we've been looking forward to in terms of telling our story. We're about 70 people in the company, growing now every day, thankfully. And we have been developing chips that interface to CPU memory subsystems now literally for a decade. And we spanned 8 generations of x86 processors through DDR2, DDR3, DDR4, building custom chips that basically do very sensitive analog type timing on either side, and then growing more and more complex logic in the middle. And over the last 5-6 years, we've added huge strength in software and embedded firmware, and now we're also developing, manufacturing our own modules. And so the Memory One product, which is the one we're talking about today, is a fully vertically integrated Diablo designed product that's manufactured by CMs that we contract, and we deliver and warrant this product directly to the customers, directly to the market. So we're now sourcing all of the commodity parts that are on the product, and then everything else is the value that we're adding to it. Just slightly different from the previous business models that we had, for example, with the UltraDIMM, with SanDisk. It was kind of like a partnership. Here, it really is a Diablo product, and I think for us, we're very proud of that. We've built a stack of capability that goes from operating system level type drivers to flash management now, and clearly PCB and system integration design skills. And so it's a really, really tight, very coherent team that delivers the entire product from start to finish now. Okay, we just recently raised a very significant financing round, so we're well capitalized, and we're really looking forward now to growing our market in 2016 around what is the first of its kind, which is basically an all-flash dedicated memory product. And we'll obviously talk more about that later on. As a company, we can't do it all alone. And so now our goal is to partner with as many system integrators as we can. And we've got quite a few partners now that have come on board that are integrating Memory One. And customers can now basically order systems, start testing systems, start using systems and buying systems from a lot of our tier 1 OEM partners. You can see we're very strong Asia focus, so we're now starting North American and European growth this year. We've won a lot of awards, over the last couple of years for memory channel storage and Memory One. I don't put too much stake in this, but what it does say though is that we're trying to build products that are unique at Diablo, that are not me too. And what I want to really see, as well as the rest of the team, is have now the market growth kind of coincide with the market recognition. And the company's always been recognized for innovation and being, let's say, ahead of the curve in terms of the avant-garde. Now we want to see it translate into a real business opportunity and growth revenue for our customers, and that's kind of what we're looking forward to doing this year. Okay, so let's get right into it. So, very interesting trends in the market as people try to win the internet. The software that they're needing to win it is changing. And 5-10 years ago, everybody was very familiar with words and names like Hadoop, MongoDB. Not the fastest things in the world, not very memory intensive, but you can scale it across 1,000 servers. You could scale it across 2,000 servers or 20,000 servers. And so, large scale warehouse type computing became very important. Things like MapReduce, which, companies like Google pioneered, essentially started to change the dimension around how many computers are solving a problem and delivering a result, okay? And we got the concept of web scale computing. The memory tier, that is usually fronting a database, became extremely important to get good response time over the internet. And so what you saw was, they weren't the fastest things in the world, but as long as it was running in memory, it was okay. Okay? And now what's happening is that people are trying to move functionality into that quick memory tier. Okay, so they want responsiveness, which is, hey, I look something up on Google and boom, it's there. And everybody kind of knows what memcache is, right? It's basically the version of the thing that was searched for in your general geography. All right, somebody could have searched for something similar. The other side of the world is another version of what you actually saw on your computer over there. And that's the cache. And that, how Google and some of these guys keep that all coherent is their secret sauce. The thing you need to remember, though, is it's in RAM somewhere. It's not on a disk, not on an SSD either. It's in RAM, and that's why you can get it reasonably fast. So what people now are trying to do is they're trying to be intelligent about what they do with the data, the queries. And I heard somebody talking about metadata before. I mean, all these things are really trails of information that surround the thing that you're looking for. How many times did that person look for it? How many times has it been looked for in certain geographies? That's information that people can use to make money in advertising and targeting products towards you. And so really analyzing trends and information and doing convergence, right, around that piece of information require some type of, reasonably fast in-memory analysis. And that's what things like Spark and Redis allow us to do. They allow us now to actually start doing work in the fast area of the tier. And it's no longer just a cache now. It becomes a functional business-generating engine. And so the natural thing is to say, well, how would I do more with it? Well, one of the key things happens is that you need more memory for it. And I've spent the last months, if not almost a year now, talking to companies, and they're clearly migrating from, I had only 64 gig in my Hadoop server, to now I need 256, and even that's not enough. It's like I'm really stuck. And I can honestly say this, the DRAM, outside of the CPUs that Intel is developing, the memory is clearly the most constrained and most expensive piece of that puzzle. And that's the problem that we're looking to solve with Memory 1. And we want to solve it with flash, okay? And there's nothing complicated about that. Flash is extremely cheap. It's very, very power efficient, okay? And it's very dense. And we're going to talk about it later, okay, but what about all the bad things, right? And we're going to address that. You know, we're going to talk about how we step aside all the bad things that flash kind of carries with in terms of baggage. But let's just focus on one thing. Flash is available. It's a jelly bean. It's a really, really accessible commodity, and it's much more cost-effective than DRAM. And so, of course, we're going to invest tremendous energy trying to find a way to use it along with DRAM, not instead, along with DRAM to increase the capability of that tier that's in the internet, which is a huge market. It's a huge opportunity, and it's a great place for this type of technology to exist in a large scale, and that's what we want. Okay, so...
Sorry, I have a question.
Yeah, go ahead.
So Intel it will be very soon on the market with 3D XPoint, which has some sort of similar numbers to show at the moment. So it will be your competitor, probably.
Yeah, you could think of that, think of it that way. Similar numbers is a bit of a misnomer, and I'm gonna talk why. I think our products are complementary. Okay, and I really mean that. First of all, Intel is an amazing company. They have amazing technology, and obviously they own the processor, and therefore they define the architectures going forward. I mean, it's obviously a validation of what we've been working on for at least 5 years as a company, right? The concept of a hybrid memory system. There's one difference. You know, at least what I've read and from what I know, they talk a lot about half the cost of DRAM. Okay? I can tell you that flash is orders of magnitude less expensive than DRAM. So there is a very different economic model that comes around flash. There is a very different sourcing model that comes around flash. And I think that that's a very powerful weapon. So if you're a company that's consuming, let's call it 5 to 10% of all the servers in the world, you know, I can tell you which one you would be very interested in putting in your 100,000 server fleet, right? And all of these systems still need DRAM. So one of the things I want people to be sensitive to is, you know, half the cost of DRAM is at the component level. But like we all know, you know, one thing about DRAM is there's only DRAM on the module. You know, when you look at a DRAM module, there's just memory. There's like a little logic chip on there. It costs like $1, you know, but the rest of it is DRAM. A lot of these other memories, including flash, have power regulation. They have ASICs like ours that convert things and do things. They have firmware running in them. There's a lot of overhead that comes with it. And you know, the nice thing about flash is it's so damn cheap compared to DRAM is that you can still offer the customer, you know, a hell of a deal and still absorb all that and make good money. Okay? So I think you got to focus on this piece here, which is why I think they're complementary. All right? A lot of the data that I'm going to show you today is when you're running systems 100 at a time or 5 at a time or 300 at a time on a network. Unfortunately, you know, the network and congestion in the server and things like that are kind of slowing everything down. And it'll be hard to tell the difference, frankly, between the flash and the DRAM in a lot of applications that people kind of really care about when they're doing it 1,000 servers at a time. So there's not really a lot of room there for performance optimization. And so then it really becomes about, well, which one is doing the job and costing me less and taking less power, and hey, I can buy it from 5 companies, okay? So again, I think the market is huge, and clearly the products, in my opinion, will coexist. I can't imagine that Diablo would win the whole market, and Intel would, you know, and nobody, frankly, wants Intel to win yet another whole market. They already have the processor, and so there are some headwinds against that, and I think most of them are flash has been around for decades, and it's available from 5 fabs. And you'll see today, it's damn fast. It's faster than people think. And the reality is the market is going to end up being split in some ratio, and I'm okay with that. Right? And so, time will tell. But one thing that's amazing is that this is true now. Right? This is true. The days of the memory system is only DRAM and it cannot be anything else are frankly over. Okay, our stuff is working, it's out there in the field, it's being consumed right now. It is a hybrid memory system designed for enterprise use. When we talked about Intel, when they come out, this is also no longer true. It's a hybrid system designed for enterprise, and DRAM is not the only game in town anymore. And so, what we want to see is we want to see basically hybrid systems take over. It's a huge market. And I think that's the key about all this, is that we're going in a direction that's clearly being validated by the biggest processor vendor in the world. Amazing company. And, my guess is we'll split the market, and a lot of it will be the guys who are really focused on performance will want it, and the guys that want it good enough, will want something else. Hopefully memory one. Does that make sense?
Yep, totally.
Okay. So Ricardo, so that cache level is like L1, L2 level cache within the memory hierarchy per se. Is that kind of what you're portraying there? And then when we talk about 3DX, there are some changes, I guess, going into the DIMM interface to support that. Do you believe that you'll be compatible with that over time? Or because, they're going to have a lot bigger address space, just like you guys do, to some extent. I know you're doing like mem paging and stuff like that in order to support that, but it's unclear what the hell they're going to do, quite frankly.
Well, it is unclear, and I don't want to start talking about how this stuff works, okay? But you asked a couple of different questions, and I'll try to answer them. Okay? First of all, this memory module, the one that Diablo is developing, which is memory 1, doesn't need anything different than a standard DRAM module, and it never will, okay? So as long as the server can support a DRAM memory module, which of course all servers going forward will, JEDEC standard, we don't have any compatibility problems. So this today does not need any hardware changes in the server, does not need any hardware changes in the CPU, does not need any application changes. It doesn't need anything like that. So what it needs is the UEFI in the server to identify it as a memory 1 module. It sets up all the address spaces appropriately, and we move on. Okay, and that's done by those partners that I talked about before, right? Guys like Inspur. The user, the customer, has nothing to do except put software on and go. Okay, so in terms of, let's say, what we would need, we don't need any specific changes. Now, in terms of 3D XPoint, there may be enhancements that Intel would have made to allow communication between the onboard controller, their version of our chip on this, to communicate directly with the host with less overhead or, better latency. Yeah. We don't have the ability to get CPU changes, and so we make do with what we have. They may have optimized that, they may have added some signaling, but I think what it would be is a superset of the JEDEC standard, not a subset of the standard. And therefore, as long as we keep behaving like a DRAM, which we do, there shouldn't be a problem in terms of compatibility. Okay, I can't speak to enhancements that they may have made.
Right.
Does that make sense?
Yeah, perfectly.
Okay, so yes, this is L1, L2, L3. This is the, what was historically the memory, which is expanded now to have 2 types of media, DRAM and flash. And then you have the storage domain, which, spans from high-performance PCIe cards all the way down to Rust, right? Okay. So now, there's what it is and what it isn't it. And I think sometimes it's as important to understand what something isn't than to, to understand what it is, because there is confusion in the market, and I'm a little bit of a bigot when it comes to, okay, well, what does my product do and what doesn't it do, right? And I'm religious about making sure that people really understand how they can use it, and most importantly, not be deceived about being able to use it when they really can't. Okay, and I'm actually going to kind of go to this side first and then work my way back. Because it's flash that we're using, a lot of people think, okay, well, it's persistent, right? It's not, actually. We designed this product to be like DRAM, and there's a lot of performance reasons for that, but we designed it like DRAM. If you pull the plug, well, the data you had on this thing is gone. Now that's good. You know, like even though you think it's bad, it isn't. The goal is to make DRAM expand, right? Cost less. And applications, when stuff is in memory, they don't care if it goes away. If they want to save it, they put it somewhere in storage, right? This is not a storage product. It's a memory product. And so we're not carrying the cost and the overhead of capacitors and crazy commits and all that stuff. We play so many games now with when applications dirty pages and write things. We play lots and lots and lots of games to get amazing endurance, amazing performance, seamlessness in the system, and no changes to the application at all, right? Applications don't care if they lose what's in memory because they know it's in memory. And so one of the most important things is this is using a non-volatile media, which is flash, but it's actually not an NVDIMM, right? The non-volatile DIMM. And so in terms of persistence, the answer is no. Unlike the Ultra DIMM, which was a storage product, and when you wrote something, you know, in less than 5 microseconds and it came back and said, I got it, it had it. This thing has no concept, right? Neither does the application, because you can't commit something to memory today, right? You can't say, hey, I have it locked in memory, you're never going to lose it. You have to lock it into some storage thing. Even if it is on an NVDIMM, you still need the concept of a software storage layer that says it's committed, okay? So it's not persistent. And so if we work our way back, you know, an NVDIMM and DRAM, pretty similar performance. Now I say slightly different because if you really want to use this as something where you know data's on it and you'll never lose it, there's a bit of software overhead. You can't really access it exactly like memory, but it's still pretty damn fast, okay? We are not as fast as that, and that's okay. We're going to talk later about why that is totally okay, right? But we're still pretty damn fast, and you'll see later that this is much faster than any storage product that's on the market, but it's behaving differently. It has different optimizations. We can't do things that they can do. They can't do things we can do, and that's okay. They're different products. They coexist in a server. Memory and storage coexist. Actually, we see lots of customers that have memory one and lots of SSDs. Fantastic. They're totally different functions, totally different features, right? Sorry, you were going to say?
Yeah, so the NVDIMM actually had some software surrounding it in order to page out memory pages and stuff like that into a memory address space. Does the Diablo Memory 1 have that sort of capability, requirements as well? I mean, the software layer, software storage layer on top of that? Or is it just memory?
There is absolutely a software component that goes with this.
Okay.
100%. 100%. It doesn't just show up as memory magically.
Yeah, no.
You have to make it happen with software.
Okay.
But not at the application level, right? You do not have to change the application to use this product. You do not have to change your operating system to use this product. So it happens under the hood, but there is software, 100%.
My understanding at the NVDIMM didn't have it at the application layer, but it did have that mapping in between, right?
Yep.
Okay.
Yep.
So is it a BIOS driver then that you're loading in? Where like you say, there's software runs somewhere.
If you're willing to wait,
okay,
he is going to explain it all.
Okay.
Oh,
we definitely have that in there. Just
all right, I can wait.
You can do it.
My question, I suppose, is why am I doing this? Is it because it's slower than memory, but it's bigger and cheaper?
Definitely.
Okay.
If you don't care, if you don't deploy 10,000 servers a month, you might not care. If you deploy 10,000 servers a month, like the customers that we care about do, you're saving thousands of dollars per server.
What if I'm interested in deploying, terabyte memory database kinds of things into, or even multi-terabyte memory databases? Wouldn't that be a viable solution?
Yeah, of course.
That would work with your system, yeah.
Yeah, but then what happens is, though, it's like, okay, when money is no object, you can solve that problem many different ways.
Yeah.
Right? So again, it all becomes a question of, he asked, why are you doing this? Well, usually people that are doing it, money is an object somehow, or there is a limit. They're trying to do so much on so much data that they can't really do it across 10,000 servers, but they could do it on 1,000. Like what we see is when scale is a problem or when cost is a prohibitor, they jump on this product.
I have a question here from Howard Marks. Can you execute code from Diablo memory? One?
Okay. That will also be explained later, but the CPU is always reading and writing data physically into DRAM. That's his question. And the answer is it doesn't execute code out of us.
Okay.
Okay, and he's going to explain, Mara will explain in a few slides how that could be or how that is.
Right.
It's a fundamental, by the way, if I'm not mistaken, in terms of something like, 3D cross point, it's a similar situation. That's why you can't completely throw out the DRAM and replace it with something else. In general, the CPU's dirtying pages and operating on the cache, you really want it operating out of DRAM, right? And then what happens is the DRAM operates as like a write-through cache or some level for the larger media. So if you go back to this, the DRAM or a portion of it becomes like an L4, right? That's the concept.
Did I hear you right earlier? Are you aiming your product and betting the business effectively on making it with, is it a small set of huge customers?
No, it's not aiming and making, but what happens is I think it's natural to go where the problem is the biggest, the demand is the highest, and the least number of people can have the biggest economic impact. Okay, and what I mean by that is if I have a customer that could potentially buy 100,000 of something, I got to invest the same engineers and support on that type of customer to someone who's going to buy 5. And actually, a lot of times, the guys who buy very little are really good at kicking tires for about 2 years, right? And then they're going to make one big purchase for them, which is a huge purchase, but they're going to invest tons and tons and tons of time, okay? So I don't have any qualms saying, I'm okay with that. Like if you're a company that's a certain size, i.e. Diablo, and you got to point your guns in certain places, you're going to go where you're going to have the biggest bang for your buck, literally. And it turns out that there's at least about a dozen companies in the world that if one of them bites, hey, they can make your business. Now, the nice thing is that most of their needs are similar to the other guy's needs, and the other guy's needs, and the other guy's needs. And so if you look at most success paths to $1 billion, they usually had a couple of whales attached, right, to that business plan, because it's much easier to land a couple of those than 3,000 dolphins. And so it's not a question of betting a business, it's a question of putting the focus where it's needed. Now the nice thing is with the emergence of the cloud, what we're seeing is that there's a lot of cloud operators and a lot of, let's call it Web 2.0 type companies that are maybe not deploying 20,000 servers a month, but maybe 500 to 1,000. And that's an amazing customer too. So I think we want to go after customers that are worth our time in the early days that are buying a lot. And this is a product that is not top of pyramid. Like in my view, we want to attack the bottom of the pyramid where people are buying a lot. And the guys that are buying a lot are really, really interested in getting a better return on investment on their infrastructure because they're bumping up against data center costs, they're bumping up power, electricity, how many people they can get on a server in terms of return on investment in the cloud. That's a big thing now. People are spending like crazy in the cloud, but they're not making money, so they got to find a way to get less infrastructure cost and more revenue per machine. I just think it makes sense, right? It's not a question of betting a farm. It's a question about being smart. Hey, that's where the money is. That's where we're going to go. Okay, so it is a little slower. we can make do with that. We'll talk about that later. It has, less bandwidth. But, the software stack on this is actually a limiting factor. And you see, and look at the papers, million IOPS, 2 million IOPS. Turns out we can do the same. And we'll show you that today. But memory is the one we really care about. Now, this is where it becomes important. This module is a DRAM module that has flash added to it so that you don't lose the data. Okay? It's designed for very specific things. People that are running file systems, that when the system goes down, they don't want to lose the metadata on file systems. It's a very specific, narrow use case. Okay? DRAM is, of course, very generic, and Memory 1 is designed to be very generic. Okay? So this product has its place in the market, but you can see that it's a very different product, actually, from what we are developing. And so, when you see NVDIMM in the market and you see capacities of 32 gig or 16 gig, it's okay. It's a different product. Just don't compare it to Memory 1 and vice versa, right? This is designed to be memory. This is designed to be storage. Okay? Okay, so how does a server look? We have two major flavors, 1 terabyte server and a 2 terabyte server. It's not that complicated, right? And, one's got 128 gig of RAM, physical RAM. The other one's got 256 gig of physical RAM. And you either have 8 128 gig modules or 16. Right? And so you can see there's usually a 1:8 ratio in terms of the DRAM to flash. Of course, you can play with that, the software level. And we just plug into a standard 2 DPC server or a 3 DPC server. Okay, standard Intel processors, 1 TIB, 2 TIB.